In this video we're going to look at two more tests to determine the convergence of a series. One is the ratio test and the other is the root test, and they both have pros and cons to them, but they're both very good tests that work very well. One of the nice things about them is neither test has hardly any restrictions on it at all. So for the ratio test, the only thing we have to have is that the sum of a sub n terms needs to be a series with non-zero terms, which most series are like that anyways. So if that's what you have, there's three different cases for what the convergence might look like. For the first case, then we can say that the series a sub n converges absolutely. Absolutely, you'll recall, means that the convergence doesn't depend on signs alternating, which will make it more likely to converge because you have the positive and negative terms canceling out each other somewhat. But this guy's going to converge absolutely if, when you take the limit of the ratio, that's why it's called the ratio test, of every later term with its earlier term, if that ratio in absolute values is less than 1. The reason that works is that we would expect if a series is going to converge, then the later term should be smaller than the earlier terms. Now if they wound up being close to the same, the ratio would be 1. So to converge, we would expect it to be something less than 1. It doesn't matter what it is, this less than 1. In a similar fashion, the series is going to diverge if the ratio is bigger than 1, which makes sense. If the later terms are becoming larger than the earlier terms, then the sequence will be getting larger in absolute values, which of course will make the series get larger and larger and larger, and therefore diverge. The only downside to the ratio test is you'll notice I've left out one case. I've done less than 1 and greater than 1. If the limit is equal to 1, then we can't tell. The test is inconclusive and you're going to need to use another test. Just as a quick example of that, you can try on your own 1 over n. The series will diverge, of course, by p-series. That'll give you 1 if you try the limit test. And the series of 1 over n squared will give you 1. But clearly that converges. So you see, you could have either way. It's kind of on the fence. Now, what's a good time to use the ratio test? Well, specifically when your series contains factorials, because you would have something like n plus 1 factorial over n factorial, which factorials cancel easily by peeling off top layers of the larger factorial. We'll show you an example in a later video. Or exponentials for the same reason. If you had 5 to the n plus 1 over 5 to the n, you'll see that cancels quite easily to leave you with 5. As an example. The root test is our second test. Very little restrictions on that. This just needs to be a series. It doesn't matter what your terms are at all. It has 3 cases similar to the ratio test. The first the first condition says that the series will converge absolutely if the nth root, that's why it's called the root test, if the nth root of the absolute value of the a sub n terms is less than 1. Real quickly, why is that true? Why does that happen? Why does that make the series converge? Well, if you think about it, if the sequence terms inside the series, if they are bigger than 1, when you take the nth power of that, like let's say 2 to the n, 2, 4, 8, 16, 32 gets larger, that series would diverge. But if it's less than 1, like the first case has, let's say a half, and you take successively higher powers, a half, a fourth, an eighth, a 16th, that will go to 0 very fast and make the series converge, actually converge absolutely. I've already kind of explained the second one. It's going to diverge if the nth root is larger than 1. And again, the test is inconclusive if the limit equals 1. The root test series, you can spot those from a mile away because these are good to use when all of your terms have nth powers in them, because you're going to take the nth root, when you go to use the test. So hopefully those tips will help you. Look for the examples of these two tests to be coming soon.